In this video, we will talk about how to parametrize a circle and an ellipse. So I'm going to get into an example right away. Let's parametrize, this is a circle, x squared plus y squared equals 9. So the idea that I'm going to use to parametrize this is I know circles sort of remind me of the unit circle. They remind us of the unit circle, and the unit circle x sort of corresponds to a cosine, and the y coordinate corresponds to a sine. So also when we see something squared plus something squared, and we think of cosines and we think of sines, we think of the fact that this looks like cosine squared t plus sine squared t equals 1. So of course, it doesn't look exactly like that. So right now, I don't have a cosine in here or a sine in here, and I have a 9, I don't have a 1. But nonetheless, there are two squares being summed, and it's equaling some number. Okay, so here's how we can modify that. If we took this equation and multiplied everything by 9 and got 9 cosine squared t plus 9 sine squared t equals 9, that gives me an idea for what we can let x and y be. So I'm going to let x be 3 cosine t. That way, when we square it, we're going to get 9 times cosine squared t. Similarly, let's let y be 3 times sine t. Okay, and when we do this, when we take these values and we plug them into this equation, we end up getting 3 cosine of t squared plus 3 sine t squared, and that gives us 9 cosine squared t plus 9 sine squared t, which we know is 9. So this is going to work out when we plug it into this parametrization. Okay, so the one thing I haven't specified at this point is what the domain is and what what range of values t takes on. So let's look at a table of values and let's look at those points on a graph to give us a feel for what we want that domain to be. So this time when I plug in values for t, I need to plug in nice angles because they have to be plugged into a cosine and a sine function. So let's plug in things like 0 and pi over 4 and pi over 2, and I'll just do those 3. So plugging in 0, 3 times cosine of 0 is 3. If I plug in pi over 4, we'll get 3 times 1 over root 2, which is 3 over root 2. Plug in pi over 2, we get 0, because that's what cosine of pi over 2 is. If we do the same thing with the y, we'll get 0 here, because sine of 0 is 0. We'll get 3 over root 2 here, and then when we plug in pi over 2, sine of pi over 2 is 1, and when we multiply that by 3, we get 3. Okay, so these are a few of the points on the circumference of the circle. So if I draw this circle, so this is where 3 is on the x-axis, this is where 3 is on the y-axis. So when t equals 0, we are here at 3, 0. When t equals pi over 4, we are at this point where the x and the y coordinates are the same. So t equals pi over 4. And then when t is pi over 2, we are at this point at the top, where the x is 0 and the y coordinate is 3. Okay, so now let's think about the domain and what we want t to go from. So if I just need to describe going around this circle one time, then I could just say that t is in between 0 to 2 pi, and that'll describe going around the circle one full time. So this would be my parametrization right here. And I forgot to draw direction arrows. So my direction arrows are pointing this way, and then I keep going around in that direction. So this parametrization gave me this counterclockwise parametrization of this circle. So it's a good warm-up exercise to think about, well, what if I had wanted it to go in the opposite direction? How would I have needed to change this parametrization? Or what if I wanted it to go around the unit circle more than one time? How would I have accomplished that with my parametrization? And we'll answer some of these questions in the homework. All right, so let's do another example now. Now let's parametrize 36x squared plus y squared equals 9. So this isn't a circle. So we might recognize that this is the equation of an ellipse. The equation of an ellipse in general looks like x squared over a squared plus y squared over b squared equals 1. So an ellipse in general has this form. And to put it in that form, I need to divide by the 9. And that gives us 4x squared plus y squared over 9 equals 1. And it still doesn't quite have that form because x squared is supposed to be divided by a number. But to put it in that form, I just have to rewrite 4x squared as x squared being divided by 1/4. And now this has the form for the equation of an ellipse. So how do we handle an ellipse? Because we did circles, but what do we do for an ellipse? So my idea here is going to be to sort of mirror what we did above. And it would be really nice if this 36x squared, if we let that 36x squared be equal to 9 times cosine squared t. And then if we let the y squared, so if we let the y squared, let's put this in a different color actually. If we let the y squared be 9 times sine squared t. Because we already know that 9 times cosine squared of t plus 9 times sine squared of t equals 9. Okay, so in this first equation, if we isolate for x squared, dividing by 36, we'll get x squared equals 1/4. Let's write that 4 a little bit better. 1/4 cosine squared t. And now we could square root both of these equations. And if we square root them, technically we'd get a plus or minus. Because I am choosing this parametrization, there's more than one parametrization that gets the job done. We saw that in one of the first videos of this section when we parametrized a parabola in 3 different ways. It was the same parabola, but we just did it in 3 different ways. If we chose the positive version, the positive root, 1/2 cosine of t, we'll get one parametrization. If we had chosen the negative root, we'll get a different parametrization, but that's okay. So I'm just going to stick to the positive version. Same thing for the y. When I square root y squared, we'll get 3 sine t. And again, I'm going to let t be between 0 and 2 pi because that's going to account for going all the way around this ellipse. In this case, just one time. But note, we could also choose negative 1/2 cosine t if we had wanted to, and negative 3 sine t. It just gives us a different parametrization, which might correspond to things like a different direction or a different speed around the curve. Okay. So if we needed to graph this ellipse, if we don't remember things like the major axis and the minor axis of an ellipse based off of what a and b are, we can use this parametrized form to quickly get how far across in the x direction it goes and how far across in the y direction it goes. So cosine in general, just on its own, is always between -1 and +1. If we multiply it by 1/2, that's always going to be between -1/2 and +1/2. So in the x direction, my ellipse will go all the way to -1/2 in this direction, to the left, and to +1/2 in the right direction. And then sine is also between -1 and +1. So multiplying that by 3, it'll mean that y is in between -3 and +3. Let's just write this down. Y is going to be between 3 and -3, and x is going to be between -1/2 and +1/2. So now we could see that it stretches a whole lot more vertically than this one does horizontally. So my ellipse would have looked something like going down and then back through that point at 1/2 and then up. So it's this narrow ellipse here. All right, so let's do one more example in this video. So what if I was given something in the parametric form, x equals 6 cosine t and y equals 1/4 sine t, and I needed to convert that to xy form. So this looks ellipse-esque, like I have something times cosine t and something times sine t. So we're thinking that it might be an ellipse. So here is the idea that we can use. The common theme to all of these has been that cosine squared t plus sine squared t equals 1. If I want to convert this to xy form, I'm going to somehow have to get rid of this extra variable t. All right, so one way I can do that is if I have an equation that connects the cosine and the sine, and this equation connects them, and I can figure out what cosine of t is on its own by dividing by 6. So cosine of t is x over 6, and then cosine squared means, well, square that. Similarly, sine of t, if you multiply over the 4, is 4 times y, and then we have to square that because we have sine squared, and then this equals 1. And now I can just simplify this a little bit, simplify it a smidge, and I get x squared over 36, squaring 4y, we get 16y squared equals 1, and that is our equation purely in terms of x and y. Okay, and this is already in that ellipse form for us. Maybe it would be slightly better if, to see if this is an ellipse, to move that 16 to the bottom and write it as y squared over 1 over 16. And now it matches the form that we said an ellipse should have up here. Okay, so this was an ellipse. All right, so returning to our goals for this section, we have now talked about how to parametrize ellipses and circles. In the next video, we will briefly talk about how do we handle things that are not lines, not line segments, and not ellipses, so other curves.